Hey everyone, and welcome back to the channel. Have you ever looked at a massive pile of geochemical data and felt like it was just staring back at you, full of secrets, refusing to give up its hidden treasures? Or perhaps you're a geologist who spent years meticulously analyzing samples, only to wish there was a faster, more accurate way to see what's truly beneath the surface. Well, today, we're diving into a topic that's not just changing, but revolutionizing the way we understand our planet: the incredible power of artificial intelligence, machine learning, and advanced statistics in geochemistry. For decades, we've relied on traditional statistical methods to decipher Earth's hidden language. And while these methods have served us well, they often feel like trying to find a needle in a haystack, a very, very large haystack, constantly growing. But now, with the advent of AI and machine learning, we're unlocking a whole new level of understanding, transforming geochemistry into what some are calling the new geophysics.
The data challenge. Why traditional methods fall short. Let's be honest, working with geochemical data has always had its quirks. We're dealing with immense datasets, often unstructured and filled with millions of individual measurements and observations. It's incredibly easy to get overwhelmed, and the sheer volume of this data is growing exponentially. Traditional analysis methods, while foundational, are often time-consuming and labor-intensive, taking hours, days, or even months of manual processing. And even then, the risk of human error is always lurking, which can be incredibly costly in the high-stakes world of mineral exploration or environmental monitoring. One of the trickiest problems for geochemists, especially with compositional data where all elements must sum to 100%, is something called the closure problem. Imagine you're trying to understand the relative proportions of ingredients in a cake. If you know the percentages of flour, sugar, and eggs, they must add up to 100%. But what if your analytical method slightly overestimates one ingredient or underestimates another? This closure can distort the real relationships between elements, leading to misleading interpretations and making it incredibly difficult to see true correlations or build reliable models. It's like trying to figure out if more flour makes a cake sweeter when your measurements are already subtly skewed. The complexity of Earth's geochemical systems only adds to this challenge. We're constantly dealing with intricate relationships between various elements, compounds, and geological processes, often hidden beneath layers of complicated basement geology, weathering, and deep cover sequences. A mere meter and a half of certain gravels can completely hide the signal of the underlying geology. Trying to understand these systems with traditional tools can feel like trying to solve a giant, ever-changing puzzle with only half the pieces.
So, how exactly do these advanced techniques work their magic? Overcoming the compositional data conundrum with CODA. This is a big one. Compositional data analysis CODA is a specialized statistical framework specifically designed to tackle the closure problem. Instead of looking at raw percentages, CODA focuses on the ratios between elements, often using clever mathematical transformations like log ratios. This approach ensures that statistical analyses, like calculating averages or correlations, are meaningful and don't get tripped up by the fixed sum constraint. It's how we can finally get accurate data interpretation from our geochemical data, allowing us to pinpoint geochemical anomalies with confidence. Advanced mapping and discovery, seeing what was once blind. Imagine finding deeply buried mineral bodies that were previously invisible. 3D geochemical modeling is a game changer, allowing geoscientists to create incredibly accurate and detailed subsurface models. This is combined with data from geophysical surveys, like magnetics, IP, and mount to delineate underlying geology and highlight prospectivity mapping for elusive targets, even large blind porphyry deposits. Furthermore, remote sensing geology, especially hyperspectral imaging from satellites and drones, detects subtle alteration zones on the surface, guiding our geochemical sampling to the most promising areas. No more random walking around with a pan and shovel, hoping for the best. Enhanced efficiency and automation, the need for speed and accuracy, the days of waiting months for lab results are slowly fading. The industry is rapidly moving towards real-time geochemistry and mineralogy while drilling. Thanks to innovations like portable XRF instruments, essentially a mini-lab you can hold in your hand, geologists can rapidly analyze samples on-site. This data is instantly fed into cloud systems, allowing for real-time adjustments to drilling strategies and efficient drill core analysis. This drastically improves mining efficiency by reducing unnecessary drilling and minimizing the environmental footprint of exploration activities. No longer does a drill rig have to be demobilized while you wait for lab results. It can keep working, adapting on the fly.
Predictive analytics and smarter decision-making, this is where things get truly exciting. Multivariate analysis and unsupervised learning techniques, such as principal component analysis (PCA) and cluster analysis, are used to define distinct geological units and identify complex mineral systems and their elemental associations. These methods are crucial for advanced grade control systems in open-pit mines. They can incorporate blast movement modeling to predict how blasted rock moves, ensuring that valuable ore doesn't accidentally end up in the waste pile and optimizing dig limits to maximize profitability. Imagine predicting nutrient transport in agricultural watersheds or groundwater quality with unprecedented accuracy. Machine learning algorithms are proving incredibly effective in environmental geochemistry, helping us manage our planet's resources more sustainably. Building trust with explainable AI. As AI models become more complex, it's not enough for them to just give us answers. We need to understand how they arrived at those answers. This is the realm of explainable artificial intelligence (SI). It provides insights into how complex machine learning models work, fostering trust and enabling better informed decisions in critical areas like environmental and earth system sciences. We don't want a black box telling us where the gold is. We want to understand the geological reasoning behind the prediction. This ensures that human expertise remains central to the decision-making process.
The future of geoscience, integrated and insightful, the future of geoscience is here, and it's built on the seamless integration of diverse data streams. Geochemical, mineralogical, petrophysical, and geophysical data are all coming together in 3D geological models and sophisticated digital environments. This digital geology approach, supported by advanced analytics and AI-based tools for data cleaning, leveling, and imputation, is transforming geochemical exploration into a more robust, integrated, and insightful process. Imagine a world where geochemical data, mineralogical data, and petrophysical properties are all routinely collected and streamed in real time while drilling. This lab-quality real-time geochemistry and mineralogy while drilling is a technological leap, providing geoscientists with a rich, multidimensional view of the subsurface that was once unimaginable. Coupled sensors, like those on the Curiosity rover exploring Mars, are making their way to Earth, combining chemical and mineralogical analysis into single, rapid systems. This will allow for instant feedback and more precise decision-making in exploration and mining. This isn't just about faster data collection. It's about transforming that data into actionable information and knowledge. The challenge now lies in effectively dealing with the big data issue that geophysicists have grappled with for years. We need to develop advanced data platforms and analytics that can handle the sheer quantity of information and turn it into insights that support strategic decision-making and exploration targeting. Of course, like any powerful tool, AI and machine learning are not magical solutions. They depend heavily on high-quality data, thoughtful model selection, and careful human interpretation. There are still limitations.
Data quality. AI models are only as good as the data they're fed. Cleaning, leveling, and imputing missing geochemical data are crucial steps before applying advanced machine learning. Processing algorithms. The hardware for data collection has advanced so rapidly that processing algorithms are sometimes playing catch-up. There is a huge opportunity to develop smarter software that can turn raw wiggly lines into clear, actionable information for geologists. Texture information. While we can predict bulk properties, automatically measuring and integrating textural information like sulfide connectivity, which affects electrical responses, remains a significant challenge. This is where the experienced eye of a geologist looking at drill core or samples is still irreplaceable. Sociological implications. Generating terabytes of data daily raises questions about how we, as a community, will cope with and interpret all that information in real time. We need not just data engineers, but also log engineers, and highly skilled professionals who can translate this vast ocean of data into meaningful knowledge and guidance for decision makers. Despite these hurdles, the journey is exciting. The emphasis is on collaboration between geochemists, geophysicists, data scientists, and engineers. It is about combining the strengths of traditional methods with cutting-edge approaches to unlock the full potential of geochemical data. The future of geochemistry is here, and it's a future where human expertise, creativity, and problem-solving skills are amplified by the power of artificial intelligence. It's a future of groundbreaking discoveries, more efficient operations, and a deeper, more sustainable understanding of our incredible planet. So, are you ready to take your geochemical analysis to the next level? The Earth's secrets are waiting.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.